Before we end this lecture video, let's have a quick summary and few add-ups. We all know that thermal strains are strains that develop when a material is heated or cooled. This means that this happens when there is a rapid increase or decrease in temperature, which then causes the body to expand or contract. So if temperature deformation is permitted to occur freely, no load or stress will be induced in the structure. In some cases where temperature deformation is not permitted, an internal stress is created, which is also known as thermal stress. Meaning, if the deformation is unrestricted, mag-elongate continuously ang object since wala may restrictions nga mag-limit sa iyaha nga mag-elongate. So, there will be no thermal stress, only thermal strain. Partially restricted, if ang deformation is partially restricted, so since na may wall or barrier na mag-restrict sa iyaha nga mag-elongate further, then it will have a limited elongation. And para mabalik siya sa original position, there will be an internal stress which termed as thermal stress. So, in partially restricted, there will be thermal stress as well as thermal strain. So, if ang deformation naman kay totally restricted, walay thermal strain since maka-elongate ang object since dili maka-elongate ang object tungod kay naamay ga-restrict sa iyahap sa pag-elongate. So, no elongation, no thermal strain. Pero naa siya thermal stress because naay internal force nga ga-act atong object. Okay. Moving on, let's have the equations that can be used in problems related to thermal strain and stress. So to solve for the amount of deformation due to change in temperature, this is given by the deformation due to change in temperature, which is equal to the coefficient of the thermal expansion times the delta T, which is the difference in or the change in temperature times length. And to solve for the deformation due to equivalent axial stress, this is given by the deformation due to load, which is also equal to P, which is the force or the load or the pressure times length all over area times E, which is the modulus of elasticity, which is also equal to stress times length times modulus of elasticity. So these two equations are the general equations that will be used in solving thermal strain problems. On the other hand, applications of thermal strain to everyday life are evident in different structures. So this includes electric wires in posts, railways gaps, wheels on iron rings. But it does not limit only to those structures. Thermal strain is also evident specifically to expansion joints, thermostats in temperatures, I mean thermostats in thermometers, engine coolant, and etc. Also, sa balay, the concept of thermal stress and strains can also be observed. Like, the concept has, so like, kanang pag-chismis sa mga chismosa, it is an unrestricted elongation. Ngano? Kay why honong storya 24/7. Walay undang, walay limitations, and ilang storya kay unrestricted deformation like gasigi lang nga gasigi. So, other pod kay sa balay, kanang kibali pagkasab-an ka kay naglaag ka tas may pananghid, nagyaw-yaw na si mama ug si papa, tas ikaw ni bukha mong baba kay lagi gusto ka mo defend sa imong self. Pero naay thermal stress nga nag-restore sa imuhang jaw from its original position kay kabalo ka nga mali ang pagtubag-tubag. So, and that is the partially restricted deformation. Kay limited o tungod sa katon, limited lang ang pag-elongate sa imuhang baba. Og kana pong kuan, mawala ang internet connection ang inyong wifi. So, mag-open ka og Google. And walay elongation sa bar sa ubos sa search button kay wala siya ga-move kay lagi wala ka internet, and that is totally restricted, wala nag-elongate. So and that wraps up our report. We are hoping that you all understood everything about thermal stress and thermal strain at this moment of this lecture video. Keep safe and thank you for spending your time with us. Adios!